This video will cover finding sector areas like these when it's more than one sector, like number 23 when we've got 3 pieces to deal with. But it will also cover how to find the area when it's the area between 2 shapes, like an inner shape and an outer shape. So let's take a look at number 22. If this were just one sector, as soon as we see that we're dealing with a sector, which is like a slice of pizza, immediately we're thinking, let's do part over whole equals part over whole. Now on the right hand side, this part we're doing degrees. Partial degrees over all the degrees. On the left hand side, we are doing area. So the area in the top will be the area of the sector, and the bottom will be the area of the whole circle. So let's set that up, but let's be very, very careful about how we do it. Normally, when we go to do the degrees, we look for the partial degrees that is showing, like this 43, and we put this 43 right here in the top. But in this problem, the 43 is not the angle that we want. We will not put 43 here because it is the white angle, and we're trying to find the shaded sector, so we need the number of degrees for the shaded area. So since this is a diameter, it's a straight line, 180 degrees, I can just subtract from 180. So if I go 180 minus 43, that's going to tell me how many degrees the blue angle is. So obviously we're going to get 137. So now bear in mind that there are 2 of them, but 180 minus 43 is 137. Okay, so it's the 137 that we're going to deal with. Now if this were just one sector, I would put 137 right here. And I'd go, oh, 137 out of a total of 360. But there are 2 of them. And I want to find the total area of both. So instead of putting 137, I'm going to have to double that. So 137 times 2 is 274. So we should all put 274 up here. For people that space out, let me just leave a side note that this was 137 plus 137. Now we can go ahead and finish the problem. We're looking for the area of the sector, that partial area. I like to use a lowercase a for the partial area. And down here will be the whole area of the whole circle. Now we know that the area of the whole circle can be found by pi r squared. Area of a circle is pi r squared. The radius is 6, so the area of this circle is pi times 6 squared, which is 36 pi. So that's what we're going to put here, because this is the area of the whole circle, part over whole. So all we have to do is cross multiply. Now we should reduce this just to make the numbers a little smaller. 274 over 360. It reduces a little bit, not a lot, but it becomes, so I'll have a over 36 pi equals, and this reduces to 137 over 180. Basically both of these were just divided by 2. So it's not a big improvement, but let's go ahead and cross multiply from here. So 180 times a should equal, now I have to do 137 times 36. So that is 4,932 pi. Don't forget the pi. So now I need to divide both sides by 180. So divide by 180, divide by 180. Okay, so this is going to give me my answer. Let's see if I can do an exact answer and a decimal answer. Okay, 4,000 divided by 180. So first let's see if we can reduce this fraction. See if the calculator will help us. Come on. Alright, so if we do 4,932 over 180, see what we get. So that's 137 over 5. Okay, so an exact answer would be 137 over 5. Now, I just reduced the numerical part, but the pi is still there in the numerator. So this would be an exact answer for the area. I should include those units. That's centimeters, square centimeters. But of course, I can turn this into a decimal very easily. I would need the pi back in there. So 137 pi over 5. Okay, so that is 86.08. Okay, so that should be the area of the sector. Both sectors put together. Don't forget your units, squares, centimeters. Alright, number 23 is a similar deal. The only big difference is they don't actually give you the degrees, any degrees. Like this one, they gave us the 43, which we had to subtract from 180. This one, they gave us nothing. But they did tell us that all of the pieces are equal. So if I want to find how many degrees each piece is, I could either take the entire 360 and realize that there are 8 pieces. Alright, so if I do 360 divided by 8, that turns out to be 45 degrees. Or I could have done 180 divided by 4 if I kind of look at a semicircle. Either way, each one of these sectors is 45 degrees. So that means the 3 sectors that we are paying attention to are each 45 degrees. Okay, so again, we'll need the total of those to do the problem. So just be careful about that. So it's going to be very similar to the last problem. We're going to do part over whole equals part over whole. So we need to know kind of what is 3 times 45. Okay, that turns out to be, I believe, 135. Okay, so that is 135. Let's put a little arrow there. Over 360. Alright, the partial degrees, the shaded degrees, out of the whole. We're still looking for the partial area, so that'll be A, and we'll still do the total area. So again, off to the side, I will calculate the total area. Area of a circle is pi r squared. In this case, the radius is 13, so that's pi times 13 squared. So the total area is 169 pi. Alright, that's why I'm going to have 169 pi right here. Now let's see if this reduces. So 135 over 360, that's 3 over 8. So that's A over 169 pi is equal to 3 over 8. So if I cross multiply, that's going to give me 8a is equal to, let's see what 3 times 169 is. That's 507. So that'll be 507 pi. Don't forget the pi. Now we just have to divide by 8. So dividing by 8 on both sides. So that's going to give us the answer. So really, if I wanted an exact answer, this would be it. 507 pi over 8. What's this? Square inches. So this would be my exact answer right here. All right. If I want a decimal answer, I can go ahead and put that in the calculator. I really recommend doing it as a fraction though. So this would be 507 pi over, what was it, 8? Over 8. Please do it as a fraction. So that's going to give us 199 point, I'll have to round this up to, so 0.10. Inches squared. Okay, so this would be the decimal answer. All right, just one more time, let me emphasize this. 507 pi divided by 8. You know what, maybe that would turn out fine without. Okay, anyway, no, I'm just going to move on. So, last one. If you want to find the space between two shapes, okay, that space between the shaded area is always going to be the outer shape minus, that's an R, by the way, minus the inner shape. Alright, so the area of the outer shape minus the area of the inner shape. So in this case, the outer shape is a big circle, and the inner shape is a smaller circle. So we will find the area of the outer circle and subtract the area of the inner circle, and that should leave this donut area. Okay, so let's see. The area of the inner shape is very simple because, in both cases we're going to do pi r squared, right? Because they are both circles. But for the small circle, the radius is right there. It's 9. So that is pi times 9 squared. We have to be a little bit more careful for the big circle. Do you think the big circle is going to have a radius of 3.5? Am I going to do pi times 3.5 squared? Of course not. I mean, I say of course, but every year I have students that do that. The 3.5 is just this little piece. It is not the entire radius of the large circle. So what am I going to do to find the whole radius? Yeah, I'm going to take the 9 and the 3.5 and I'm going to add those together. Okay, so the whole radius here, from here to here, 9 plus 3.7 is 12.7. So that is the radius of the big circle. So I'm going to be doing pi times 12.7 squared. Okay, so let's see, what is 12.7 squared? Okay, well that's kind of an ugly number. So I think we'll just go straight to the decimal. For this one, it's not going to really be possible to get any sort of a clean exact answer. So we could just put the whole thing in the calculator. Alright, so let's just do this because I don't want any rounding until the end. So what we have is pi times 12.7 squared minus pi times 9 squared. So that gives us 252.24. Meters squared, because we're dealing with area. So that is it. Alright, so anytime you want to find the space between two shapes, do the outer shape area minus the inner shape area, and that will give you the space between, like this. Alright, I hope this was helpful. I will see you on the next video. Please give me a thumbs up. Like me.